All right, so in this video, we're going to see what happens to entropy when we mess around with temperature and volume. So as a little precursor to that, let's write down temperature here, and let's write down volume here. And one of the things that we know to be true is that whenever we raise the temperature, gas particles tend to move, or liquid particles, or any particles for that matter, move more rapidly. So that would make our entropy change greater. Similarly, if we were to lower the temperature, we'd have less disorder and our overall entropy change would be less. Volume works the same way. If we increase the volume of something, particles are going to move around much more freely. They have more space. That's much more disordered. Conversely, if we lower the temperature, you can see that it's not the temperature, lower the volume, we can see that the entropy change is going to be negative as well. So in both these cases, if the temperature and the volume are both going up, we know that our entropy change is going to be positive. We're going to end up more disordered. If both of these go down, we know that our reaction is going to become less disordered, and then we're going to have a negative change in entropy. Where it gets a little bit tricky is that if one of these doesn't change, and actually it's not tricky, it makes it easier for us. Let's say the volume doesn't. Oh, I did not want to erase that. Let me just get that back for us here. Let's say our volume here does not change. Then the only thing that's going to impact our entropy is going to be our temperature. So if our temperature goes up while the volume stays the same, then the entropy would go up. If conversely this stays the same and my temperature goes down, the entropy will go down. The opposite is also true. If I were to hold my temperature constant and I were to raise my volume, I'm going to have more disorder. And if I were to hold my temperature constant and or lower my volume, I'm going to have less disorder or negative disorder. So let's apply this right now to our problems. So they give us a starting point here, but really we care about what they're saying over in this area. They tell us that the acetone evaporates. So if we go from a liquid and it evaporates, doesn't that mean that my volume is getting bigger? Simultaneously, we're holding it at a constant temperature. So we're making this not do anything, and then we're making our volume go up. So therefore, our entropy change is going to be positive. We're going to have more disorder. So we're going to fill that in over here, and we're going to write this as more disorder. So let's take a look at the next one. Here we have helium is being cooled. So we know that our temperature is going down. But again, in this case, the volume is being held constant. So we're going to ignore that and just look at the temperature going down. And as you can see, if the temperature goes down, then we're going to become less disordered, and our change in G is going to become even less. So over here, we're going to have less disorder. Finally, let's take a look at this one. We have carbon dioxide being heated, and also it expands. I know I wrote right through the middle of that. So if we're looking over here, we've increased the temperature and we've increased the volume. Under all circumstances, wouldn't our change in S be getting bigger or positive? So over here, we're going to write this down and say that our change in S in this case here is going to be greater than 0. Hopefully this has helped you. Have a great day.